Okay, hello everyone. This is my senior capstone project, the SOS box or sauce box. My name is Tanvi. I'm a senior here at Grandview High School, and all my life, science and math have been my favorite subjects, which has pushed me to be an engineer in the future, and I'm really excited. I love to design and create, which also involves my engineering passion. At Grandview, I'm a varsity diver and I'm on varsity track. I do Key Club, FBLA, and NHS, and I'll be attending Purdue next year to study engineering further up. So my inspiration for my project rooted from the cause of safety for young children, especially children who are not at the age that they're responsible enough to have a phone. So I decided to create a form of communication and safety for young children to communicate with their parents. So the solution I have is a panic button, which I disguised to look like a sunglasses case. Originally, I wanted to make a watch, but I think my expertise level is not at that point yet. So having something a little bit bigger to work with was the route I wanted to take. And basically what this does is when you press a button, it would send a GPS location to a different cell phone or website, or I'll show you what it is in the picture. So obviously this project was not able to be done alone, and I had some guidance throughout the process. I have my two expert advisors, Bumsy Reddy, who is a software engineer, and he's helped me with coding and really formatting my ideas into something that's actually creatable. My dad, Jitta, who is an enterprise architect, and he has a degree in electrical engineering, so he's helped me with the electrical side and creating code for my Arduino. And then my mom and Doreen, who are my support advisors, who help me also learn my ideas, and for someone I can talk to when I need help with formatting my ideas. So this is my logo I decided to go with. It's red, which communicates danger, and then it's small and it's related to GPS, which is basically what my project is. My project objectives is that I wanted to find out my coding skills, because in the day that we live in, I think code is a really important thing because that's how the future is going to be. I wanted to gain more of an exposure to the world of engineering because that's the field I'm going to go into, and I feel like this is a great project to help me improve my experience. I wanted to complete a research project from start to finish, and I wanted to improve my public speaking skills, which I'm here today. And I wanted to prototype a simple version of a possibly complex device, which I created up here. And so my general timeline to finish this project by April is basically to start with just researching GPS, and then also learning C++ code, which I'll be using in my project. And then for my code, I would start with coding the Arduino to read a GPS location, and then coding that GPS location to work when you push a button, and then towards the end, March and April, to send that GPS location to an email or a text message, and then assembling my project in April. So basically, a GPS works with a bunch of satellites that are in space, and they collect information, and from there they can be translated into many things, but for this project specifically, these things called enemy A strings, and these strings would be used in the Arduino library, which I'll be using for my project. And so initially, I thought I was going to use a Raspberry Pi and use Python with 4G hats and GPS hats, but after further research and consideration, I thought an Arduino would be a much more feasible route to use because it's smaller, it's lightweight, it's more energy and power efficient, and then C++ code just works better with Arduino, so I thought I should probably learn that instead of Python. And then the Arduino shield is a GPS shield, which instead of using an antenna, it's just a small chip that it's a lot smaller and compact. So this is a specific Arduino board I decided I'd use. It's part of the Maker series, which is a series that is really good for IoT devices or Internet of Things devices, which sends information from device to device. And it has the ability to use an external power supply, like that battery up there, or a portable charger. I decided to use a portable charger for my project because then it's rechargeable and it's more convenient. And then it's pretty similar to Arduino Uno, but it's a lot smaller. It's about like that big, so which would be nice to make it compact. And then I would use an Arduino Maker shield, GPS shield, to actually read the location. This is really convenient because it uses an I2C cable to connect, so I wouldn't have to solder anything. And it stacks right on top of the Arduino Maker board, so it's really convenient. And so to start my project, I started by learning C++ code, and obviously I'm no expert, but I just learned the basics of the code and get myself familiar, so when I looked at a piece of code, I could understand what I was looking at, and I could also recreate pieces of code. I used this guy called Programming with Mosh on YouTube, and he has an entire crash course that I watched, and I did the practice experiments on there. And then I created a cheat sheet to help me and refer back to when I'm actually creating my code. So once I familiarized myself with the code, I got down to business, and I started making the code to actually read the GPS location. I used lots and lots of Arduino forums to do this, which is basically people who have problems with Arduino, and they put their problems up there, and people help each other. So those really helped me along this process. And I researched new functions that are related to reading GPS code, like float latitude and float longitude. But then when I upload the code, there was one word to describe this process, and that was problems. If anyone using Arduino knows, sometimes there's lots of problems with uploading code to your board, and especially with this, I could not get it to upload, and I've spent like weeks and weeks on this, maybe like a few weeks. And I did lots of research, and lots of people online also had the same problem uploading code specifically to this board, and I could not figure out what the problem was because my device just would not show up when I tried plugging it in and uploading the code. I looked at my terminal, and Arduino would not show up there either. And so I researched what are possible solutions to this, and one could be that the drivers in my computer aren't installed, but I thought that was not the problem because my computer is really new. And then the wire that I use to actually upload the code is only for charging devices and not for transferring data from device to device. So I thought that could possibly be a problem. So I tried 4 different wires, and none of the wires worked either. So I thought maybe it's because I'm using a MacBook, so I tried it on Windows, that didn't work either. So after this, I walk into my STEM projects class one day, and I see one of these micro USB wires just like laying on the computer. So I thought, okay, let's just try the wire one more time, and it worked. So I don't know why, but I thought these wires would work. They didn't, but I finally found a wire that would work, and it was really relieving, but I guess that's just part of the engineering process. So I uploaded this code, which just reads location from the GPS shield and transmitted it onto a serial monitor. And this is it working. It just shows the latitude, longitude, altitude, and ground speed and number of satellites of the board. And so I tested this by just moving it around and seeing if it would change with when I moved it. And it did, so I was happy about this. And so the next step was programming the button. So when you press the button, it would send a location or display the location on a serial monitor. And so I just created this simple setup on my breadboard, which when you press it, it would work. And then I integrated this code into my GPS code. And then I tested this by pressing the button in front of my computer, and the altitude showed up as 1,769. And I stood up on my chair, pressed it next to the ceiling, and the altitude was 1,772 feet, or meters, so I knew the button was working when I pressed the code. And then for the GPS to actually send a location, it needs to be connected to Wi-Fi, which I integrated this code into the code. So I went step by step by first reading location, then using the button, and then connecting it to Wi-Fi. So I put all this code in, and then this is what displayed on the serial monitor, and that's how I knew that it was successfully connected to Wi-Fi. And then once I did this, then the next step was to send that code to an email. Originally I wanted to do a text message, but then the code would have to be different for an Apple or an Android because of different things. So I thought sending an email would be a lot easier, and I used an API, which is an application programming interface, which is basically like if you have a Lego set, but you don't have the instructions to build the Legos, the API kind of acts as the instructions to send this email. And so I use SendGrid as my API server. And I put myself as the host email, so when you got the email, it would say it's coming from me, and then you can change out who you want that email sent to. And then this only works if you have Wi-Fi. So at first, it did not work because my Arduino would not connect to Wi-Fi again. But after testing it with LEDs blinking on my board when I knew the Wi-Fi was connected, and the email was sent successfully, and this would be displayed on my serial monitor. But I went through several phases of getting my user endpoint or my user interface of how the email looked. So at first it just said this, it said you have an emergency, which is not very helpful. So obviously then I added the actual location of what the Arduino was reading. So it would give me longitude and latitude coordinates, which is more helpful, but also it's not as user-friendly because you'd have to copy and paste that to Google Maps or Apple Maps. And so then I made it have a link to a Google Maps. I did this by using a Google Maps API, which had a certain API key. And so this was also getting better, but still not as user-friendly. So finally, I made it look like this. So when you click the Google Maps button, it'll take you to exactly where that location was reading. And so that S is where the location read from our Arduino. And then once I had all the code working, it was going good, I set it up on my breadboard, and then I had to start assembling the box together. And that's just a wad of paper that I put behind the button, because every time you press the button, it kind of like bent the button back a little bit. I didn't want it to damage the pins on the button. So that was just to help it from not bending back. And then this is the final product in its box. It's right here, and it has two layers. It has a leather sunglasses case and then an actual bag on top. And then if you press right here, that's where the button is. And then, or right where my finger is on that picture. But then last night, as I was testing it one last time to present it today, I was plugging my portable charger into the USB port, and I pushed it in a little bit too hard, and I broke the USB port off, and I might have had a little bit of a mental breakdown, but it's okay, because I knew it worked, and it still works, but I would need an actual battery pack and not a portable charger, because the battery pack plugs into a different part of the board, which that would take like a week to get here, but it's okay. So that's the broken USB port right back, and that is my battery pack my portable charger doesn't work anymore. And that's the battery I would need for it to actually work, which if anyone has one, please let me know, I'll take it. But other than that, I'm really proud of what I did accomplish, and I think I learned a lot through this process, especially from start to finish and learning from my mistakes, and creating a research project from start to finish. So, does anyone have any questions?
Do you plan on continuing this project?
Yeah, if I have the resources in college, I would love to continue this, and I'm pretty sure Purdue has lots of resources as super candidates. But yeah, I definitely want to improve this and make it better. I thought about adding a camera to it too, so when you press the button, it would actually show where you are and what the danger could be. Todd?
Did you ever think about, I mean, you said it has to work with Wi-Fi. You said you want to continue it. Is there plans to make it work with like a cellular network?
Yeah.
So it would just be something you take on your cellular plan channel or something?
Yeah, that's definitely something I thought about during my process, because Wi-Fi is obviously really helpful, but except when you're not connected to Wi-Fi. So having a cellular version of this board, or maybe like a connector in with it, would help with cellular data.
I had a question similar to Ty's, I guess. So when you started, I was thinking it had to be on Wi-Fi, but how is it then connecting to Wi-Fi? Like,
Oh,
what
yeah.
Wi-Fi does it hop on?
So basically the board, the Arduino Maker board that I have, it has built-on Wi-Fi compatibility. So in the code, I don't know, wait, it might be over here. You have to specify the SSID and the network password. So
So you're already programming it into
Yes,
the
it's just-
Wi-Fi network.
yeah, right there where it says the constants up there, that's my home Wi-Fi network, and then where the red boxes, that's the password. So if you just specify that, the board will automatically connect like your phone does if you put in your phone and password.
So, two small questions. So, number one, if you were to make this into like a different shape that would be, because I don't know, maybe it's just me, but like I feel like I wouldn't find a sunglasses case on a kid, so like that would make that sound plausible. But it's like a really good like idea. I just think it would be more helpful for like a like an older audience. So like if you were going to make it into a different shape, what would it be?
Well, originally I did want it to make it into a watch because I feel like that's a lot more convenient, but that would involve a lot smaller pieces, which I don't think I have the expertise level and experience to do yet. But that's also something I could do in the future when I have the ability to do so, for sure.
And I'm going to be so honest, I kind of forgot myself.
Anything else?